Greetings, I'm Roberto Messa. I'm a Brazilian Java developer and future Python developer. I work with Java since 1998 and I witnessed a lot of attempts to make heterogeneous transactions work. An heterogeneous transaction is the one that uses more than one transaction manager. For instance, you use a SQL database server transaction manager and a messaging system transaction manager, for instance, Kafka. If you try to put a sequence of SQL operation along with a Kafka send message operation, and one of them fails, the system will be inconsistent. If the SQL operation succeeds and the messaging does not, the system will be inconsistent. Otherwise, if you put the send message before and it succeeds, and the SQL operation after and it fails, the system will be inconsistent. If that happens, the system will be inconsistent and someone will have to notice, someone will have to fix it, and losses will occur. So, heterogeneous operations do not work. They never did, and I don't think they will ever work in the future. The only thing I notice until now that works is the homogeneous transaction. If you have to send a message along with the SQL operation, you gotta use the Outbox pattern. The Outbox pattern is a sequence of operations in which the business rule is executed and a message is recorded within the same database, within the same transaction. That way, if the first operation, the business operation, succeeds and the message recording fails, the entire transaction will be rolled back. That is, it is an ACID operation. And vice versa, if you want to send a message before and execute the business rule after, if the business rule fails, the entire operation will be rolled back. The system will stay consistent along the time if you use the Outbox pattern. So what are the steps to build up such a system using the Outbox pattern? First thing, you gotta create a set of tables in the subscribers and the emitters of the messages. In the sender part of the system, you will need a table to persist the message, and you also need a table to record the subscribers and the status of each subscriber. On the other hand, on the receiver side, you will need an inbox table to receive the message and to keep data to track the last message recorded there. We'll use an example of a product API and a delivery API. The product API will receive an API call, a Lambda call in our case, to record a new product. When the product API records a new product, it also records a message in the Outbox table. On the other hand, We have the delivery API, which is a delivery system. Whenever a new product is recorded, a new delivery must be recorded. The messenger system must read the inbox table in the delivery system to check out what was the last inserted ID from the product API. The messenger system will then get the last ID and will fetch from the Outbox table in the product API all the records that came after that ID. If an HTTP status 200 is returned to the messenger system, the transaction was successful. Later on, there will be another scheduled Lambda operation that will read the message in the inbox table and will create the delivery records in the delivery table. After the messages in the inbox are consumed and the delivery records are created, the message in the input box may be deleted. And to complete the messenger system, a scheduled lambda is necessary to delete all the records in the outbox table in the product API according to the data governance policy of the company. Thank you very much for your attention. If you like the content, like it, subscribe our channel, and leave your comments below.